Okay, so in this video, we'll solve some questions about calculus. So the first question is A, which is they're saying if y, they're saying if y, if y equal to 2x to the power 5 minus 4x cubed plus 3x minus 2. So they're saying the first question you need to say is you need to what? Find the first derivative, which is the y or the x. So in this situation, we'll just derive this one or differentiate. This 5 times 2, your answer is 10 x to the power 4. Then minus 4x power 2 plus 3. So that is your first question. Then the second question is the second derivative, which you have to say y to the then y over the x squared like that. Then your answer will be what? Will be 14x 3 minus 24x. So that is the second derivative. Then they're also saying that we need to find again the third derivative, which we have to say, we have to differentiate this for the third time. The 3y over the x3, then will be 120x squared minus 24, like that. Then we need also to derivate this for the fourth time, which you have to say d to the power 4 y over x to the power 4. Then we derivative is for the fourth time, which we have to say 2 times 120, it will give us 240. So this is how you answer question 6. Question 6A 1, 2, 3 up. Then let's go to question 6B. So the question is, how do we answer that question? So we answer that question by doing this. Now the question is saying if y equal to cos x minus sin x, then evaluate x in the range which is x is less than x, or x again is less than what? 270. So that is B. So how do we answer that one? We have y equal to cos x minus sin x. Now the first thing here is this. Since this part here, if you look at this part here, they're saying that you have to derivate for how many times? Twice. That's when you can equate to 0. So first thing that you do here, let's differentiate this for the second time. Let's differentiate the y, the x. This question. When you differentiate a cos, it becomes a what? Negative sin x. When you differentiate the sign, it becomes positive. Because now since here it is negative, so it means that you just leave it just like that, x like that. When you differentiate it again for the second time, so because we have to differentiate that for the second time, meaning that let's differentiate this. When you differentiate this becomes the positive, so it will be positive what? Negative cos x. Let's differentiate that one, it becomes negative what? Sin x. That meaning that it will be y squared over x. That then you have negative cos x and cos what? Sin x. Now the question is saying that d y dx and x there equal to 0. So the second derivative supposed to be equal to what? Equal to 0. So now, since the second derivative is equal to 0, then what you do is you equate the same question 0 to 0, second derivative. This is second derivative, so we have to equate that 0. From there now, what you do next is you need to solve this equation, right? So the question is, how do we solve that equation? That's where you have to go. So remember that it's what? It's negative cos x plus sin x equal to 0. Then what you do here, we can solve that, meaning that we have to divide everything there, right? By what? By cos. Let's divide everything by cos. Why are we doing that? In order to come up with the correct what? Equation. So here your answer will be negative 1. This and this, the answer is 1. So it will be negative 1 plus tan x equal to what? 0. Then your answer will be tan x equal to, then this one will go on the other side, which is supposed to be positive 1. And what you do there, you have to find the value of x, which is tan inverse of 1. And x equal to 45. So 45 in radians. Why are we using the radians? Because here the range which have been given is radians. So let's put that one in what? In radians, which is supposed to be what? It will be pi over 4, like that. So those are in radians. Now, if you look at here at this point, it's positive, right? Since it's positive, meaning that we have to get the quadrants in which tan is positive. So the quadrants at which tan is positive, it is in the first quadrant, again in the what? Third quadrant. So how do you do that one? We have to say solutions, or x in short, right? In short, say solutions will be x equal to theta over 440, then again theta over 4 plus 80. Why plus 80? Because in this quadrant here we add, so it is 180 plus theta. That's why we are doing that. Then theta. So for the second question, it says given that 2x equal to negative 3x, like that, then they're saying that show that second derivative plus 6 times first derivative plus y equal to 0. So in this situation, what do you do if you have something that is like that? You need to first differentiate the first derivative. So how do you differentiate this one? Now, since here we're having two equations, meaning that we need to use what we call the product rule. So the product rule, how does it go? It is u v prime plus v u prime, like that. So what is your u in here? The u here, it is 2x. Then what is your v? Your v is e to the power negative 3x. And what's your u prime is 2. And what's your v prime is negative 3e to the power 3x, like that. Then meaning that your dy dx, what is your u? 2x. Then what's your v? Negative 3e to the power 3x. Then plus, what is your v? V is e to the power 3x. Then what's your u? 2. Then you have negative 6x. Here it will be e 3x plus 2e to the power 3x, like that. Now, that is the first derivative. We need to find the second what? Derivative. So the question is, how do we find the second derivative? Which is, the first derivative is dy dx is what? Negative 6x, then e to the power 3x plus 2e to the power negative 3x, like that. That's your first derivative. Now let's find the second derivative, meaning that the 2 dy over dx. Now when you look at this, we're still having two functions, right? Now we use again product rule. And how do we use the product rule? We can go direct, it's fine. You first write your negative 6x like that. Then you differentiate the other part, which is 3x, 3e to the power negative 3x like that, plus then what you do, another thing will be e to the power negative 3x. Then you differentiate the front part, which is negative 6 like that. Then meaning that your second derivative in this situation will be negative 6x, then that it will give us positive 18x, then e to the power negative 3x, then minus 6e to the power negative 3x like that. So here you have the first derivative and the second derivative, right? Since we have the first derivative and also the second derivative, meaning that it will be very easy now. So what's your first derivative? Your first derivative, which is dy dx, here is negative 6x, then e to the power 3x plus 2e to the power 3x. Then the second derivative, what are you having on the second derivative? Which is d2y over the x2 equal to positive 18x, then e to the power 3x, then minus 6, right? Remember that this side again, we didn't finish that. This is on the second derivative, so we have to differentiate this part, meaning it will give us what? Negative 6. Because why would it be negative 6? Because we differentiate that part, it would be negative 3, then 2, then e to the power 3x like that, meaning it would be negative 6 like that, then e to the power 3x when you finish that. Now there you have this, right? If you check, the powers are just the same, so meaning that the second derivative you have dx, second derivative we have 18x, then e to the 3x, then minus 4e to the 3x like that. So that's your second derivative, right? Then from there, now you know what you do? You substitute on the one which is saying you need what to prove. So the key point here is you need to know how to differentiate. That's the most important thing, because if you don't know how to differentiate, meaning that it is very difficult for you to come up with the correct answer. So remember that we're showing that this part is equal to 0. So here, what is the second derivative? The second derivative is 18x, then e to the power 3x minus 12, then what? E to the power 3x plus 6 times the first derivative is this one. So you get the first derivative, which is that, which is negative 6 like that, right? X e negative 3x plus 2e to the power 3x plus 9. What was the first question? Plus 9, right? What was the first question? It was 2, or the y. The y, it is this one here. This is the y. So that's why you shall see that I'll get the y where there's 9, then y. You get the y. which is the given equation. What's the given equation? Is 2x, then e negative 3x close, then equal to what? 0. Then you say 18x, then e to the power 3x minus 4e to the power 3x. Then 6 times 6, what's the answer? It is negative. Is what? Negative 36. Like that. X, then e to the power 3x plus 6 times 2 answers 4e to the power 3x plus 18x to the power negative 3x equal to 0, like that. Now, the next thing in here, what you do is we put the like terms together, right? 18x e to the power negative 3x. Again, we have plus 18x e to the power negative 3x. Then you have minus 36x, then e to the power negative 3. This is x minus 4e, then negative 3x, then plus 4e to the power negative that equal to 0. Now, what's the answer here? This is 36x e to the power 3x. Then that side minus 36x e to the power negative 3, then plus 0, because when you subtract here, the answer is 0. How about this side? When you subtract here, the answer is 0. 0. Then you say, hence what? Hence John. Just like that. So, that's how you answer question C. Now, let's go to the other question, which is question D. So, the other question, which is question D. The question is, what do we do when you have that? They're saying the function f of x is defined for what? Is defined f of x is defined for x is less than x to the power 3, right? By what? By the function f of x equal to root of 3, then 4, then minus what? 3x. So here, if you see this part here, this is the first derivative or the first differentiative, right? So how do we do that one? That's where you have to say f of x equal to, you need to put that in exponential form. That is to the power 1 over 3, like that, right? Now, when you differentiate once here, it will be, how do you differentiate it? Remember that we use the chain rule. So, you get the power, which is 1 over 3, differentiate inside, which is, when you differentiate inside here to be 0, then here to what? Negative 3. Then from there, you say 4 minus 3x into the power 1 over 3 minus 1, such that this and this will divide, then you have negative 1, then 4 minus 3x. When you subtract 1 over 3 minus 1, when you do that, you have 1 minus 3, meaning that it will be negative 2 over 3. So here it is negative 2 over 3, like that, right? So this is your first derivative. Now the question is saying we need also to find the second what? Derivative. So let's find also the second derivative, because that's what they're saying, right? On the first question. Now the second derivative, you have the first derivative, which is negative 1, then 4x minus 3x to the power negative 2 over 3, like that, right? Which is just the same as the first derivative, sorry, which is just the same as negative 1 over then 4 minus 3x to the power 2 over 3 is also equal to cube root of 4 then 3x then you what? You square. It's just the same, right? Now let's find the second derivative. So the second derivative in this situation will be negative 1 times negative 2 over 3. Differentiate inside, it will be 3 here, right? Then it will be 4 minus 3x, then negative 2 over 3 minus 1, like that. Such that you have, this is negative, negative, then, negative times negative, that is positive, then positive 2 over 3 times that, meaning that it will, this and this will cancel, then you remain with 2 here, right? Remain 2 there, then 4 minus 3x. Then when you subtract there, your answer will be 5 over 3, which is this just the same as the second derivative will be negative 2 over 4 minus 3x to the power 5 over 3. Then it is just the same as 2 over root or cube root of that, which is 4 minus 3x, then 5, like that, right? So from there now, you have the first derivative and also the second derivative. Now let's go to question 2. Question 2, it says the first, the second, and the third of the geometric are f of 1 and f of what? 1, f of the derivative of 1 and the second derivative, which is of 1, right, with times k. Now you have that. What are they looking for? They're looking for us to find the what? The k. Now what do you do in this situation for the second one? So you do like this for the second one. You do it like this on the second one. So what is your f of x? Your f of x was 3, then 4 here minus x, right? Now you have to find f of 1, which is then 4 minus 3, 1. Then it will be 3, then that is 3 times, that is 4 minus 3, right? Such that your answer will be 1 here, right? Then what's your answer? The answer is 1. So that is your f of 1. So that's the second question. Then the other one is the second derivative of, what's the second derivative that we found? It's 1 over 1 of what? The one that we found, 3 here, right? Then 4 minus 3x. Then here we had 2. Now let's put 1 wherever there's x. We're just substituting here. Wherever there's x, you put 1. The derivative in that situation is 4 minus 3, then 1, then square, right? So in that situation, it will be 4 minus 3 again, is squared, right? So, the second derivative here, we had 1 again, right? So it's 1, like that. So meaning that down part would be the cube root of 1, meaning that the answer still remains with what? 1. So meaning that f of 1, the answer is negative 1. Then the second derivative, we had 2 over now on the second derivative, they have put k like that, right? Then 1 inside. This is what they have put. So meaning that you start with, you put k times negative 2 over root of 3 here, and 4 minus 3, then you put 1 like that, such that you have negative 2k over, when you do this, which is 3 here, right? And that is 4 minus 3, then 5. Down here, make sure you put this 5. So we have negative 2k like that over. If you see everything here to be what? To be 1, then it will be negative 2k. The cube root of 1, the answer is 1, such that your answer is what? Negative 2k. So kf of second derivative of 1, we have found that, right? Now let's arrange them. So here, let's arrange this. The f of 1 is 1, right? Then the f of the derivative of 1 is negative 1. Then k, the second derivative of 1 is what? Negative 2k. Now we have 1 comma negative 1 and negative 2k. Now the question says the first and the second and the third term of the geometric here, right? Of the geometric, and we have already found f of 1, f of the f of, that is the first derivative of 1, and k, the second derivative of 1, right? We have found all of them and we've put them in that, and I've said that then what? It's what? Geometric progression, meaning that they have same what? Common ratio, meaning that the common ratio at 2 is equal to common ratio at what? At 3. Is it okay? Or common ratio at 1 is equal to common ratio at what? 2. So you do like this, say R2 over R1. You do this for you to do this. So here you need to find the common ratio at 1. So meaning that it is second term over the first term is equal to third term over second term. Now what's the first term or what's the second term is negative 1 over 1 equal to negative 2 over negative 2k over what? Over negative 1, such that you multiply this negative 1 times negative 1, then 1 times that, meaning that you have something like 2k equal to positive 1, then you divide by 2, divide by 2, such that your k is equal to negative 1 over 2. So that is how you solve those questions. Just like that. Simple and straightforward. Yes. So make sure you follow, subscribe, share, like, comment. equal to pi over 4. When you add there, you get your answer, which is what? 5 pi over 4. This is how you solve that question. Now let's go to the another question.